Hello friends, this video on respiration in plants part 18 is brought to you by examfear.com. No more fear from exam. So now that we have discussed about both aerobic and anaerobic respiration, we will quickly talk about a new term or a new concept called respiratory quotient. Now, what is respiratory quotient? This is a parameter which is used to measure how good a particular substrate is behaving or how good a substrate is performing as far as the process of respiration is concerned. The respiration is all about taking in oxygen and giving out carbon dioxide, right? That is all about respiration. So if I am talking about aerobic respiration, so in case of anaerobic respiration, this quotient will always be infinity because there will be no oxygen taken in. Right, so forget about that part. For aerobic respiration, if we want to measure which substrates are better at respiring with low requirement of oxygen, so we need some parameter to measure it. So that parameter is respiratory quotient. So let us see how have we defined this parameter. So this is the ratio of volume of carbon dioxide released to the volume of oxygen taken in. So as I said, respiration is all about taking in oxygen and giving out carbon dioxide, right? During the process of when I am talking about respiration, that is what happens, correct? If it is aerobic respiration. So how much carbon dioxide is given out divided by how much oxygen is taken in, that is respiratory quotient. So CO2 out by O2 in. So this ratio will actually tell us how much carbon dioxide is the particular substrate capable of giving out when it takes in a particular amount of oxygen. So this is denoted by RQ, and this is also known as respiratory ratio because it is a ratio of two volumes. So it is also called respiratory ratio, and this is a dimensionless number. Now, the value of respiratory quotient varies with different respiratory substrates because every substrate will have its own capacity to give out carbon dioxide when given a particular amount of oxygen. So let us look at some of the different substrates, what is their respiratory. So let us talk about carbohydrates, and carbohydrates also let us talk about glucose. So glucose is C6H12O6. So when glucose is oxidized, carbon dioxide and water is formed. So this is how the equation looks like for complete oxidation of glucose or for complete respiration of glucose. So what would be the respiratory quotient in this case? That is number of molecules of carbon dioxide, which is 6, divided by number of oxygen taken in, which is again 6. So the respiratory quotient is 1. Similarly, let us look for fats. For example, palmitic acid. So what is palmitic acid? It is C16H32O2 plus 11O2 gives C12H22O11, which is the sucrose, plus 4CO2 plus 5H2O. So this is the balanced equation for complete oxidation of palmitic acid. So here the respiratory quotient will be the number of molecules of carbon dioxide formed, which is 4, divided by oxygen used, which is 11. So 4 by 11 is 0.36. So this is the respiratory quotient for palmitic acid. If you talk about other organic acids like malic acid, there you will see that the respiratory quotient is quite high. In fact, in some of the organic acid, it goes high up to say 4 or 5 also. So malic acid is C4H32O11. C4H6 and O5. So this is malic acid. So when this is oxidized, it forms 4CO2 plus 3H2O. So in this case, the respiratory quotient will be 4 by 3. So which is equal to 1.33. So here if you see, some of them have a respiratory quotient less than 1, some have greater than 1, some have equal to 1. So what do we infer from this? What do we conclude from the value of the respiratory quotient? Now any substrate which has a respiratory quotient less than 1, for example the palmitic acid, it means that this substrate needs more oxygen for respiration, because in this case it produces less carbon dioxide. So even though so much of oxygen has been supplied, it produced quite less carbon dioxide. So if you want it to respire really well, you want it to give out more carbon dioxide. So in that case, you have to provide more oxygen. So if the respiratory quotient is less than 1, that means you need to supply more oxygen to that substrate for better respiration. Whereas if the respiratory quotient is greater than 1, for example in case of malic acid, it means that the respiratory substrate contain more oxygen and therefore it needs less oxygen for oxidation. It does not need that much of oxygen for oxidation. And if it is 1, that means it is the ideal scenario. It has the correct amount of oxygen which is required to respire. Right? So that was all about respiratory quotient. Thank you. Please visit www.examfear.com to watch more videos, attempt free online test, get free study material, find tutors and mentors. Thank you once again.